All right, so let's do a quick example using the r theta or polar coordinate system here. This is a great example of this. In this case, we're given an angular position and we're relating it to a radial position of where this ball is in this track. We understand that as this thing starts to spin up, we'll see this ball accelerate outwards. And once we reach a certain time, the ball will fly off this track. But we know that this is the relationship that we observed with for theta and r based on time. Now, the first part that we know, if we're trying to find velocity and acceleration, my first suggestion whenever you approach a problem like this is get out your, I would say, the steps that I would follow to solve this sort of problem. First, I would try to approach this by find our r dot, r double dot, and find our theta dot, and theta double dot. Remember that we often call this angular acceleration or angular velocity, omega, and this is angular acceleration, alpha. These will come up later when we start looking at later chapters and specifically relative motion or absolute motion, rotation about a fixed axis. We'll see these alpha and omega symbols show up in there. So first, let's find those things here. So we have these defined in terms of our time of 1.5 seconds. We have a function of r here, so we could find that derivative. So that's going to be taking derivatives. After we have those bits, we can find v theta and vr using our values. And then moving from that, we can use that to find a theta and ar using these values. So that's going to be our general plan of attack here.